right, so now that we have our expression for A, what we'll do is we'll revisit our original function, right, difference between the data and our prediction squared, and we'll take our expression for A and substitute it in. Then what we'll be left with is just an expression in terms of y, x, and b that will take a derivative with respect to b and set it equal to 0 and solve. All right, so first things first, let's go ahead and make that substitution. And we get a sum of yi minus, instead of a, we've got y bar minus b x bar plus b xi, quantity squared. And now we can go ahead and actually take the derivative of that function. We're taking the derivative of f with respect to b. All right, so we'll still use our power rule at first. We bring that 2 down, and then we have a sum, and I have yi, and I'm just going to rewrite some of this in here. We've got minus y bar. Notice that we have a b in both of these terms. This minus comes through, so I would end up with a plus. I could rewrite this as plus b times x bar minus xi. All right, so that was our first step in the derivative. We used the power rule, brought the power down, and then just cleaned up things inside. But now we notice that if we take a derivative with respect to b of what's inside, which we have to because of the chain rule, all we're left with is just x bar minus xi. Because yi is a constant, y bar is a constant, the derivative of b is just 1 times x bar minus xi. And now we just want to set this equal to 0 and solve it. We can get rid of that 2 just like we did before, and we have a sum of yi minus y bar times, we've got to multiply this by each of these terms, right? So times x bar minus xi plus b times x bar minus xi quantity squared. And I can distribute that sum also, so we could think about this as a sum from 1 to n, 1 to n. Now we want b, so we just have to move everything around, and we'll be able to isolate b. If we swap, if I move the b over, I'll have negative b times the sum 1 to n of x bar minus xi equals the sum of yi minus y bar x bar minus xi. Divide through by this sum and that negative 1, and we find b. So we have a sum 1 to n of, and that negative 1, one way I can incorporate that is to switch the direction of one of these. It would be the negative of the other. So that's another. So I'm going to just make it look the same. So I'll write this as y bar minus yi. That's like factoring in a negative 1 times x bar minus xi. And then we divide it by the sum of x bar minus xi quantity squared. And now we have an expression for both a and b and can find these values. So that's the last thing we'll do. We'll start first in just like a simple Google spreadsheet, and we'll use this to fit some data, and then we'll look at it in Python.